Bienvenidos de nuevo.
Welcome again. We're going to finish this day concerning surprising applications of technology for daily life. I have my friend here. She's an occupational therapist with over 20 years of experience in terms of support and applications in the working organization. She has worked with integration and devices and is conducting a project of innovation in terms of adaptation of jobs. In this session, we're going to share 4 projects in different phases of development using technology in service of disabled people. Welcome, Paloma. The screen and floor is yours. Thank you so much, Sonia. Good afternoon. Good evening to all. Sometimes a technology, an old problem, and a great idea become an innovation. This famous quote represents the topic today. The speakers that I'll have the great honor of introducing are applying technology to try to solution problems that disabled people face, innovating to improve independence and the quality of life of people. We will talk about animals, ultrasound, artificial intelligence, concepts that seem far away of people's daily life. However, throughout these developments, they become our allies, elements that ease our environment, that allow for the participation of people in different activities of everyday life. We'll start introducing Clara Mancini, professor of interaction between animals and computers. She has founded and directs the Laboratory of Animal and Computer Interaction. She will talk about animals and technology and why this interaction is paramount to animal well-being and to allow them to help humans. Clara, please go ahead.
Clara, the audio, Clara. Your microphone is okay.
Can you hear me now?
Perfect.
Well, thank you very much for having me here. It's a pleasure to share the work that we have been doing at the Open University and the Animal Computer Interaction Laboratory with this community. This evening, I just wanted to briefly introduce you to the field of animal-computer interaction and to explain why it is relevant to designing for diversity and inclusion. So, animals have been exposed to technology for a very long time. So to speak, technology has been happening to animals for decades. How does technology impact on animals' well-being? For example, how does those sort of wearable devices, such as the ones fitted on this seal, affect their ability to conduct their daily activities that they need in order to survive? How does technology influence animals' social lives? How, for example, in the case of these robotic milking systems, how do they interfere with their social dynamics? How easy is the technology that we designed for animals to use, such as the technology we use to test animals' intelligence? Is the technology supporting the tasks that we give them to test their intelligence, or does it get in the way? How do animals experience the technology and the interaction with technology? Is it a pleasant experience, or is it not so pleasant experience? How does technology affect animals' security and privacy? Think of all the tracking devices that we are attaching to animals, all the data that they collect. Does that matter? Is that a question that we should ask ourselves? And finally, when we ask animals to do specific tasks to support us, how does the technology that they have to interact with how does it support their task? Does it support it, or is it an obstacle to them accomplishing the tasks that we ask them to do for us? So this is the kind of question that the emerging discipline of animal-computer interaction is aiming to address. And this is a kind of question that the Animal-Computer Interaction Laboratory at the Open University was founded to address in 2011. In particular, we want to advance the art and science of designing animal-centered interactive systems for a participatory multi-species society. We have three fundamental aims. One is to investigate the interaction between animals and technology within their habitual contexts. The other one is to design computing technology that can improve animals' welfare, that can also support animals in the activities that they conduct, including the activities that we ask them to do for us, and that can foster intra and interspecies relationships, and particularly human-animal relations. And last but not least, we are very interested in informing animal-centered approaches for research and design that enables us to develop technologies not only for animals, but also with animals, with their participation as legitimate stakeholders and design contributors. Now, we have worked over the years on a range of projects that you see sort of represented here. I obviously will not have time to go into all of these, sorry, but I will be focusing on one of them in particular. So this is the project that I wanted to share our work with you today was aimed to improve accessibility for mobility assistance dogs. A number of people have taken part in this project over the years, and I want to acknowledge them. Our research partners are the UK charity Dogs for Good that trains mobility assistance dogs, among other kind of assistance dogs. A number of researchers, Louisa Ruger, Rachel Lack, Liz Cox, Shirley Gronia O'Connor have taken part, as well as, in the project, as well as engineers, Brendan Hagenheister, Kevin Dewar, Joe Mills, and Robert Seaton. So as you know, mobility assistance dogs are trained to interact with technologized environments on humans' behalf. But the problem is that the environments in which they have to operate are designed from an anthropocentric perspective. And this poses immense challenges for the dogs. So because the environments are designed, the interfaces that the dogs need to interact with, from a dog's point of view, from a dog's perspective, contravene all the best interaction design principles that we are so careful to apply when we design for humans. So we wanted to address this problem by trying to rethink how the interfaces that these dogs have to interact with are designed. So we wanted to map good interaction design principles, the sort of principles we would apply when designing for humans, onto the canine users' sensory, cognitive, and physical characteristics, so that we could design canine-centered controls that would allow them to interface with daily appliances, such as light switches, maybe washing machines, other domestic appliances, but even traffic lights or elevators, other sort of interfaces and technology that we find around in our cities. So the design that we developed was very simple. It was, we had two basic designs. We used colors that dogs could very easily distinguish between, discriminate. Dogs have dichromatic vision, which means that they see blues and yellows very well, but they don't see red and greens very well. So imagine how many controls are around in homes and cities that use green and red, because we can see them very well, but dogs can't. The controls that we designed are quite large, very easy to target for the dogs. So the dogs can interact with them using their snout instead of using their limbs. So that they pause, for example, where they have less motor control. These controls the controls we designed are very sensitive, which means that they barely need to be they need to touch them, and they activate, and they have a slight texture to allow a bit of a grip without affecting their nose too much, which is a very sensitive part of their body. So we wanted to test whether these devices worked better than standard controls that dogs are trained to interact with ordinarily. So as an experiment, we used our controls to operate a motorized door, and we tested our controls against a standard door opening control. So we measured different parameters, including some examples that you can see pictures in this slide. We checked the time that it took the dogs to open the door using one or other control. We checked how many attempts they needed to make in order to actually make contact with the controls, and we also measured how many attempts they made before they actually activated the control. So on all counts, it turned out that our controls, both the color blue and yellow, worked better for the dogs. They were able to interact with these controls more effectively. But with a preference for the blue, and we think that's because the blue was more obvious, more clearly visible against the light background on which the controls were placed. But so this showed how just trying to think of interaction from a canine perspective, from the perspective of a dog, with the characteristics of a dog, allowed us to make very simple adjustments that made it a task of just opening a motorized door for a dog much easier. We also wanted to test how dogs experience the interaction with these controls. So we looked at different ways in which we could measure the dog's experiences. Of course, dogs use their tail to express many of their moods. And so we developed a tail wagging ethogram, so a description of the different ways in which dogs wag their tail during the interaction with the standard controls or the interaction with the controls that we designed. So, and even in this case, we could confirm that the dogs seem to have a better interaction, a more enjoyable interaction with the controls that we designed, that were more centered on the dog's characteristics. Since this study, we developed a new generation of these controls, which are cylindrical, and we tried different shapes for the push pad that the dogs would interact with. One had a concave push pad, and one had a convex push pad. So what we found was that while the concave push pad was better at guiding the dog's nose towards the center of the pad, which slightly improved the interaction in terms of efficiency and effectiveness. Actually, the convex push pad was more versatile. So imagine that this control is placed in a position that doesn't allow the dog to access the control perpendicularly to the surface of the push pad. A concave push pad wouldn't really help in that case, whereas a convex push pad could be sort of approached from different directions and still work. So we then took these findings and developed a version of this design could actually be deployed. So we have a wireless version which has the advantage that the button can be placed wherever it's most accessible for the dog. And this has, obviously to power the plug can be plugged into any wall sockets, and appliances like, for example, a lamp or a kettle can be plugged into this receiver. And the dog just interacts with the button. The button can be placed where it is accessible for the dog. And we distributed some of these buttons to various people who lived with mobility assistance dogs. And we had very positive feedback, not only about the functionality and how the buttons made it easier for the dogs to do some of the tasks in the home, but we also received positive feedback as to the fact that having this activity for the human and the dog to do together actually helped develop the bond between the two. So it was something, we were told it was something fun and easy for the dogs to learn and for the human to teach, that the two could do together. We also developed a wired version, an adapted version that could be installed in public places. And this is the version you see on the right-hand side of the slide are in fact installed at a restaurant in the UK, where they are enabling the dogs of customers, mobility assistance dogs of customers, to operate the motorized doors of their accessible toilets. So these are so this is where the project is at the moment, but we of course are continuing to pursue further developments. Here is just a very short video to show you that any dog can do this, can learn to use these buttons. And this actually was done with my dogs, who are not mobility assistance dogs. So that should give you an idea how easy this is. So this is a previous version of the buttons, which is currently installed in our in one of the buildings of our campus. This is my other dog. And this is after only a couple of days of practicing. So I just want to leave you with a final message. Why is this work important? Why is it important that we give accessibility to animals in our cities, and particularly if we ask animals to do tasks for us, to help us? So over millennia, we have created built environments that are increasingly inhospitable to most of the species who occupy the land on which we have built. And at the same time, we have established segregated spaces in which animals are trapped with little control over their environment. We're now beginning to see how neither of these situations are ecologically or ethically sustainable. So designing technologically supported environments that are inclusive and that afford a measure of control to humans and other animals who inhabit them could help us redress the balance between the interests of humans and those of other species, enabling us to create a more ecologically and ethically sustainable society for animals and humans. So my final message is in relation to this is that designing for diversity and inclusion means designing for and with all those who share the city, not just the humans, and the countryside and the planet. So and when we do this, the inclusivity we extend to other animals also is beneficial for humans. So thank you very much. And if you ever, if there are questions, I'll be happy to take them.
Clara, qué interesante. Qué interesante, Clara.
Interesting, Clara. This study that you are conducting is so useful and needed. Yes, I'm going to ask you a brief question. And you just mentioned it. I know that you participate a lot on ethical conditions related to working with animals. Could you comment the ethical principle?
Yes. So it's very important for us. It is very important that we treat our animal participants just as we would treat any human participants. So if we want to do animal-centered design, we need to put the animals at the center. So we need them to consent to what we are doing. So consent is partly given by the animals' caregivers. The animals were legally responsible for them, that the humans were legally responsible for them, but it also needs to be given by the animals themselves. So we need to put so for example, in this case, the dogs we work with, to allow them to choose whether they want to work with us or not, and find ways that would entice them to work with us. We need to make sure that we always prioritize their welfare at any time. We always make sure that any species we work with, we treat equitably in the same way that we would treat anybody else. And we always make sure that what we do, we only involve animals in our research for whom the research is relevant. So if there is a benefit for the animal to participate in our research, then we will invite them to take part. If not, we won't just use them as research tools.
Muchísimas gracias.
Thank you so much, Clara.
You're welcome.
I think you opened a need to get to know more about this project. Okay, let me introduce Kevin Pajestka right now. He is CEO and founder of Tec-Innovation, and he's going to talk about a very interesting development, Work Assist, which uses infrasound sensors to give information on possible obstacles in front of them. Kevin, the floor is.
Hello, good evening. So my name is Kevin. Thank you for the invitation. The product name is now a new one. So Work Assist is the old one. The new product name is InnoMake. It's combined from Inno for innovation and MA for Marcus and KI for Kevin. So it's a very creative name. We are producing shoes which detect obstacles, and they are especially for blind people, but also for people who are motor impaired. And I know the community knows many aids or tools which detect obstacles. So why is our way the shoe which detects obstacles? Why is this an innovative way? So therefore I have some points, because the first one is the white cane is filtered out of the measurement from our system. The second point is if you stand in front of an obstacle which you know, for example, furniture in the kitchen or people in front of traffic lights, the system will go in a standby mode. So the system won't warn you because of this obstacle. The third point is we have built in an ultralight lamp. This lamp is a third way to give a feedback for visually impaired people, so not fully blind people. On the one hand, and on the other hand, the lamp can make obstacles better. There are three reasons. The second reason is the lamp lights out obstacles. And the third reason is that you are better visible in the traffic if it's dark, for example, or if it's foggy. And the fourth point is that it's a medical device, and this medical device is mounted on shoes. So who is going to leave the home without shoes? I think nobody. And so it's a very nice gadget if it's including in the shoes. And therefore, because it's a medical product, the chances are very high in the European Union that institutions like the insurances, the government, or institutions for blind people can pay this product. But it's very differently in every country in Europe. And for a short introduction in the product, I have a video for the community. In this video, you can see Günther. Günther is one of our first customers in the year of 2020. And in few minutes, he described how he felt with the using of the InnoMake, so our high-tech medical device. So you can see the video now.
The InnoMake.
One step ahead by Tec-Innovation.
My name is Günther Kral.
Text: Günther Kral, one of InnoMake's many users, 55 years old, walks through the streets, smiling.
I suffer from macular degeneration and have only 30% vision. I currently live in Vienna.
Kunsthistorisches Museum, der Inner City, der Ferris wheel.
What I really like about Vienna is that it gives me plenty of options for both cultural,
der Schönbrunn Gloriette,
and culinary activities. I like socializing, dining out, going to concerts,
a cellist,
and just enjoying life here in Vienna.
Looks very happy.
Whenever I'm out in town, on my way to a concert, for example,
walking to the zebra crossing with a white cane,
I encounter a lot of hazards.
A car passes without stopping.
These include curbs,
walks up steps,
trees, and people.
Pedestrian zone. An e-scooter swerves at the last minute.
I can navigate with the aid of a cane, but that means having to move very carefully.
Approaching carefully with a wide cane. L-shaped InnoMake attachment consisting of 2 funnels with small sensors. Behind them, a shoe with an empty metal rail in the sole. Text: InnoMake obstacle detection system for people with disabilities and emergency services in poor visibility conditions.
The InnoMake has made things a lot easier, because its sensors can detect obstacles from as far as 4 meters away.
Shoe from the top with measuring scale. Text: up to 4 meters range. InnoMake attachment. Text: innovation, high-tech, world first, waterproof.
The closer I get to an obstacle,
walks up steps,
the faster the vibration or acoustic signal becomes, just like a parking sensor.
InnoMake attachment inserted into the shoe. Text: Bluetooth link to smartphone. Changes the settings in the app. Text: remote control using the smartphone app.
It's quite simple to use. After using the app to connect the shoe, I can configure all the settings as needed.
Text: adjust feedback to your individual surroundings.
There are different types of feedback, such as vibrations,
InnoMake attachment. Text: vibration.
Audio feedback,
InnoMake attachment with shoe. Text: tones.
and LED on the shoe.
Text: light. Walks with light flashing. Passerby looking at her mobile phone. Swerves to avoid him. Walks confidently and safely around the city with a white cane and InnoMake. Finds a gap between 2 parked cars without the cane touching the cars.
For me, the best feature is the obstacle detection function, which can be adapted to individual situations.
Smartphone, changing settings in the app using voiceover.
What I like most about it is that it can detect obstacles in good time. Another great thing about the InnoMake is that it is an everyday object that I can take with me wherever I go.
Effortlessly inserts InnoMake attachment into the shoe.
I feel a lot safer with the InnoMake, and I can move around more quickly and easily in day-to-day life.
Time-lapse of attachment switching between different types of shoes.
It's like I always say, the sensor technology is like wearing a Tesla on my foot. InnoMake product logo. A dot with 3 waves facing right. Contact www.innomake.eu. Starring Günther Kral. Voiceover Martin Oberhauser. Location Vienna. Copyright Tec-Innovation GmbH.
Okay, so you saw many things about the InnoMake now in the video. I have a shoe here with the InnoMake attachment, and it was already described in the video, but I want short to explain you. Here on the back of the attachment, there is a button. So with this button, you can also make all the adjustments of InnoMake. So you don't need the smartphone. And in the beginning of the year 2022, we want also to launch the app for the Android systems. Yeah, in one packaging of the InnoMake, you can find 2 InnoMake attachments, the charger, and the accessible InnoMake app on the App Store. And yeah, we have also the possibility to order a test kit for free in the whole European Union, so people can test our products. They don't have to buy it. And in this test, people can test it in their individual daily life, because we have to say that we don't want to replace any aid. So we don't want to replace the white cane or the dog, etc. Our product is an add-on, and people can try it in these test moments where we can try it for free. Yeah, there are also several distributors in Germany and Austria who are providing it in their shops, because it really helps blind people also themselves, because many distributors are also blind in Austria and Germany. So I don't know in Spain. And yeah, that's all. So.
Qué interesante, qué interesante.
Very, very interesting. I wanted to ask you a question, Kevin. I'm thinking about those nights where one wants to get really dressed up, or maybe wear really nice shoes. Are you thinking about a design that would adapt to a shoe that doesn't have that prepared?
Yeah. Now in this case, there is built in a metal slot. So our customers can send us their own shoes, or they choose shoes from our shop. And then orthopedic shoe manufacturer can build in the metal slot into the shoe. Why? Because that's very simple to say. If I click the InnoMake attachment in the shoe, you can see they are built in an angle. So that's very important for our sensors, and I can't tell a blind user to stick it himself on the shoe. So I have to make it very clear, because it's very important for the sensor to look in the direction of walking. And we are working on projects where you can also use kind of the same of the system on other parts of your body, or for example also on wheelchairs and so on.
Pues esperamos ver ese proyecto.
We hope to see this project evolve. The next invitee is Viktorija Paneva. She's a PhD candidate at the University Bayreuth in Germany, and she's working on computation in Bremen. She's going to talk about HaptiRead, which is an interface for reading Braille. And Viktorija, you have the floor.
Thank you so much. Thank you for the invitation, and thank you for the opportunity to present my research project here today. So I will talk about HaptiRead. So at the University of Bayreuth, we conducted research in using a new type of technology, mid-air haptics, to develop a public braille display for people, for blind and visually impaired people. So, yes. Okay, so apart from the classical braille displays, which are either on paper or the electric pins, in the past there has been some research done about using other types of devices for reading braille, like for example using the mobile phone or using wearable devices, like for example vibrotactile motors, which can be placed either on the fingers or on the hand. So along these lines, we researched how we can use yet another new and upcoming technology for accessibility purposes. So first of all, I will start with explaining a bit about how this technology works. So the haptic board is composed of ultrasonic speakers, which emit ultrasonic waves at a frequency of 40 kilohertz. Now we are able to control the some parameters of the ultrasonic waves, like for example their phase and amplitude, such that we can have a focal point. We can create this focal point in mid-air. And when we do this, the user, the participant, can feel a sensation on their skin, which is quite similar to a gentle air breeze. Just if we use an ultrasonic wave at a frequency of 40 kilohertz, this frequency is not audible for humans, but also they will not be able to feel it. What we need to do, we need to modulate this wave and bring it to a frequency between 100 and 200 hertz. In this case, the mechanoreceptors in the human skin are able to perceive this type of sensation. And the modulation of the wave can be done either by modulating the haptic point temporarily. That means that we are switching the haptic device on and off, or by moving the haptic device, the haptic point, sorry. So we are changing the location of the haptic point. So this is the mechanism how we are able to render a haptic sensation on the human skin using ultrasonic waves. So there are already commercial devices from a company in the UK that has provided these haptic boards on the market, but they are mostly used at the moment for research and development purposes. So the haptic board is consisting of 256 ultrasonic speakers, and it also has a hand tracking module. So this is a sensor based on infrared camera that is able to track the hand of the user. And so we were actually in our lab, we were working with this technology for a different purpose. So we were using mid-air haptics for virtual reality and augmented reality applications. But actually, when we looked at some of the features of the technology, we came to the conclusion that this would also be something which can be useful for accessibility. So that's why we came to the idea to test HaptiRead. HaptiRead is a concept of a public display for reading Braille text. So what are some of the advantages to HaptiRead? So the device can track the hand of the user at a distance, and it can render the haptic sensation up to a distance of 70 centimeters. Also, there is no physical contact, so the sensation happens in midair, so it's more hygienic. And only the person that interacts with the interface is actually able to receive the information. So there is also an added privacy to it. And because of the programmability of the device, we can choose different ways in which we can render a haptic sensation. And this is exactly the point which we evaluate in our user study. So if we want to render Braille characters using midair haptics, what is the best way to do it? How should we render the individual Braille cells in the most effective manner? So we conducted a user study, and first, before conducting the user study, we did an iterative design process where we involved people from the blind and visually impaired community, and we came up with 3 different haptic stimulation methods, which were the most promising. So we have a constant method where all the Braille cells are rendered at the same time, a point by point where each point is individually presented, and row by row. So this was the first user study which evaluated the use of midair haptics for accessibility. And in the user study, we had 11 blind participants, and we tested 10 different characters using the 3 methods. We obtained quite good results in terms of accuracy with all the 3 methods, and with the highest average accuracy of 88% with the point-by-point method, and the mean time to identify the character was a bit over 7 seconds. So this was first initial study, and there is still research that needs to be done on this technology. One step that we would like to do is extend the study to 6 and 8 cell Braille characters, and also present not only individual characters, but also information in context, like, for example, words and phrases. And also, as you might have noticed in the results, when we tested the device, the participants of the user study did not have any experience with using this technology in advance. So the time to recognize a character was rather high. So, but if they have more training, we expect that this time would reduce. So, in conclusion, our results provide the first empirical validation of employing midair haptics for public interfaces, for public Braille interfaces. Our participants responded quite favorably to this concept. However, further development and testing is needed to fully develop the potential of this concept. Thank you.
Victoria,
I wanted to ask you a question. Were you working with deaf and blind people as well when you were doing this research? How are the deaf and blind perceiving these?
So we worked only with people with severe visual impairment and blind people. We did not work with deaf people in the user study. What I find from the feedback that we received from the people, what I found quite interesting was that they, by themselves, they came up with tasks in their everyday life where they would benefit from this type of technology. And they gave us great suggestions about how to improve the technology further. For example, some of them said that they quite like the privacy aspect of the device, that they are the only one who can get the information that the device is rendering. So for example, for situations like going to the doctor and getting a prescription, when they exit the doctor's office, they would like to read what is on the prescription by themselves, not that somebody else has to read them for them, or to have a voiceover that would read it out loud, for example, or also when going to the restaurant and reading the menu. So their suggestion was to have a wearable and a portable version of this device that they could carry with themselves and use it into their everyday life.
Eso es lo importante, Victoria, la aplicación.
That's very important, the use in daily life. Very interesting. Thanks very much. And last but certainly not least, we have Antonio Sánchez. He's a PhD, and he works in Cartagena at the university. And he's going to talk about something that is revolutionizing the experience of children and young people with sensorial limitations in the classroom. Antonio. Well, first of all, thank you very much for inviting me to participate in this event. Thanks for disseminating this information. Today, I want to talk about a project that's based on technology so that all people, especially those with a visual and auditory disability, can have the same opportunities and the same education as anyone else, and so that no one is left behind. This project, we need to see where it came from. 7 years ago, I had a daughter with a genetic problem. She had low vision, and so I decided to do whatever I could to help her. And now I know that this is her reality. This is what she can see when she goes to the theater or to a classroom, or when she wants to just relate with the environment. Now, more important than that is what she's losing. How much of this information or this communication is she losing because she can't see properly? Many experts say that the nonverbal language and so forth, being able to capture the gestures of a person, and so she's missing all of that type of communication. Now, the next question that I asked was, what can I do to help her? Because I work in engineering, I have a lot of experience. And so the first thing I did was I signed her up to the ONCE organization. And this is a fantastic opportunity for people with low vision to be able to have the help of the ONCE organization. And that makes their lives easier. The next thing that I did was I looked for solutions to be able to increase her perception, how she could get this information on the same as anyone else. In Valencia, and the people that were using different technologies, but to be able to capture that experience, they used these monoculars. I wanted to see if there was other possibilities, but I wanted to focus on something which is the experience capturing. We usually learn from experience because at the end of the day, we capture things much more if we live an experience. And so there we defined what we wanted to do, how we wanted to capture experiences, first of all, in education, and capture the experience in the classroom. We need to be able to see the blackboard, to be able to hear the teacher, and we also need to be able to receive the presentation, the video, any kind of visual information as we are listening to the presentation. It's also important And visiting different events, we realized that we need tools like changing contrast to be able to, there's a whole series of things that are essential to capture certain experiences. And that's what I want to show here in this video. This is a real example of one of the classes. This is a person with low vision, and in her tablet or mobile telephone, any device, she can see the blackboard the way she's saying it with that clarity to be able to adjust it to the minimum size that they need to be able to see it. And in any case, if they need to access information just with a movement of the finger, they can reach that information. There's an important aspect here that I want to stress. That's what we call inclusion. It's very interesting to provide access for the people with low vision. We thought it was more interesting, however, to provide equipment and solutions useful for everyone and to have equal access to information. This person is receiving the same presentation, but from a different point of view. This is individualized learning. We each learn in a different manner. So what we provide is we adjust to this capacity of each individual. And these experience is not only possible or necessary in education, it could also be to access a concert. What I'm showing here, this is one of the prestigious music concert in Murcia. And what we did is for people with retinosis pigmentaria, and it's in addition to listening to the music, they could see the gestures made by the singers, everything, to have the full experience, to live the experience. And it was an amazing experience for a lot of people who had not had this experience and have access to these experiences and these feelings. And that's why we're using this technology. For many people are using this now. A lot of associations are using this to adapt this resources in schools, at university, and they're very happy with this. And one of our big challenges now is to provide this for people who don't have any disability at all, because at the end of the day, we don't want to stigmatize anyone for using this tool, and so that we will all be equals using this type of technology. I'm very happy that this has been disseminated nationally and internationally. And we were finalists actually in a national award of startups. And one of those 555 companies, we were one of those selected. And this slogan that each person counts is really true. So I just want to thank ONCE, who has been supporting us since the very beginning and is helping us now to disseminate our idea. And it's very important that people become familiar with this. But the most important for us is that it gets into the hands of people who really need it so that they can use it. There was a child with low vision in Malaga who didn't want to go to school, a 7-year-old, and the child said didn't want to go to school because he couldn't get by in the classroom. This device really helped them, and the parents of the child really got emotional because it made such a big difference in the life of their son. I wanted to finish up this showing my daughter. This is my daughter. This is the first time she was using the system. She didn't have to get up and look at the blackboard. She can see it directly in her screen, in her digital screen. And she has this tablet that she can use. And she didn't have to sit in the front row anymore, right next to the blackboard. She could sit all the way in the back of the classroom with her friends and use her tablet and follow the class perfectly well. So it's really important to be able to integrate. And this is the size. This is how she can see the face of her teacher. And this helps her to relate and just be one more student, not to stand out because of her disability. She said she could even look and she could copy the answers to the exam that her classmate was sitting next to her, and she could copy the answers with this device. And I told her that's really not what the device was made for. But anyway, it is allowing students to fit in with their classmates. And it can be used by all people, not just people with disabilities. It's a right. And it should be it should be one of the emblems really in our society to make everyone equal. Antonio, I think that this is fantastic that your daughter has the same opportunities as everyone else to copy in an exam. I wanted to ask you a question. I've had a lot of relationships with universities and with teams that are working with students with disabilities, and I know that these teams usually don't have large budgets to buy equipment. Where are you finding funding through universities or at schools so that they can acquire this system? Is there a budget item set aside for this to make this a little bit easier to acquire this type of material, accessibility material? Well, it is true. People are becoming more aware of the importance of these things, and as society moves forward. But this aspect, the whole concept of inclusion and providing value for the whole world has really helped with that. Most universities don't buy the material for people with disabilities. It's the best way to really capture experiences in the classroom where there's a lot of online learning and so forth. You can send all of this information to home and you can select what you want to see with a quality up to 4K. So a lot of this was used, like I said, for people with no disabilities, especially during the pandemic. So this has helped us because at the end of the day, the budget set aside for disabilities is small, but to improve digital images in schools is a need. In fact, the ministry has provided more than a billion euros for this type of technology. So we're thrilled when we're asked for these devices for people that don't have disabilities as well. So that's the situation. And that was the way we were able to go forward with our research. Okay, I've taken good note about that, Antonio. I wanted to thank all and congratulate all of you for your developments, and thank you so much for sharing with all of everyone here today these very interesting developments. I think that will end this surprising technology day with a big smile of hope of the work being done by our researchers to put all of this at the service of people with disabilities. Thank you so much, Sonia. We give the floor back to you. Thanks very much, Paloma, for presenting these four researchers and their surprising projects that are fascinating elements of the environment for people with disabilities. Thank you for all continuing with us. Tomorrow will be the last day of the Congress. We'll here for you to put the finishing touch on this conference. Thank you so much.